So this week we'll be talking about reinforcement learning, what it is, what are the application of reinforcement learning in different sectors, and what is the current state of the art or the trends in reinforcement learning that is happening. So this will be the talk all about, and questions will take about the previous one, right? Reinforcement learning, you might have known that is one of the paradigm of machine learning along with the supervised learning and unsupervised learning. In reinforcement, I talked about what is supervised, what is unsupervised. What is the extra about reinforcement learning? The extra thing is about the reinforcement learning is here we will not have any supervision. The model has to learn itself by interacting with the environment through some feedback. It's quite similar to how human learns. We interact with the environment, we get to know this is right, this is wrong, and from that feedback we learn to do a task. So this is how RL thing works. So just in few slides I'll give you the snap of what is RL, few important concepts based on which the questions are based, or the assignments, or your question will be given in your final exam. So that you have to care about few important concepts, right? So RL you all know, but RL is still a very new topic for not only for you, but still a new topic for various BTech, MTech, PhD, even PhD students. This is one of the least explored area compared to supervised learning. So RL, reinforcement learning, is to learn by itself, interact with the environment and learn it by itself. In simple terms, if I have to define it. So one example is learning to ride a bike. Very famous example is how you start riding a bike. There used to be supervision, I can understand, but ultimately your feedback from interaction with the environment, you fall down, you get to know what was the good there and what was bad there, you learn from itself. So learning by ourselves is very important there compared to someone is supervising, go and sit there, just focus, state and put, don't use break and all those things, but they are that's fine, they're like a standard guidelines, but ultimately matters how you interact and you learn by yourself. So R is a kind of a approximation function. You learn a policy, you learn a function which says given a condition, given a state, what you should do. RL is as simple as that, right? And the crucial component of RL you must have learned, it is state, which is in encapsulation of what is a current scenario of the universe. Action, given the scenario, what should we do, what are the actions. Next state, it's just if you take action and in a state, you will reach to another state, which is next state. Reward is a very crucial component because there is no supervision, only the reward is the only way how you get to know from for the given state whether it was good or bad, right? So I don't know how people know or not what is the delayed reward or what is the immediate reward. These are very important terms. So you might have seen the equation r plus gamma into rt minus 1 plus gamma square into RT minus 1. So the R is the currently what we are getting is the immediate reward, and these overall cumulative reward you get at end is the delayed reward. This is the difference between these two. A very important concept, exploration and exploitation. In initial phase of our career we do exploration. In class 10 till there we don't know anything. In class 11, 12 we have quite stick to the commerce, science and physics. Like till 10 we read everything, history, geography, maths and everything, right? From there onwards we go to quite specific, until PhD will be very much specific towards what you have to do. So it's like exploration, exploitation. You explored so many things, you decided what is good for you, and you went in that direction. So this is exploration, exploitation. Explore, get the information, and with that information exploit the information which could be used to do best possible thing in future. This is how it works, exploration, exploitation. Coming to the reward, you can think it as a policy, is a state to action mapping. You all know S goes to A, and for each transition S to S dash you get some feedback from the environment whether that action was good or bad, right? So that is known as, whatever you get as a feedback is the reward. and from reward itself you learn, right? What is the difference between RL versus other approximator? There are two kinds of approximator. One is the sorry. Oh. No, these are the two paradigms: long, lifelong learning and partial observable state. What is lifelong learning? Means you have model, you deploy it, but also at the time you are getting new sample, you learn from it. Whether you have done good or bad, the loss will be again get propagated and it will be learning. So quite similar to online learning if you have learned. So coming to the few important equations that are very important. RL convergence. So these are the three conditions need to be required to be in. This question may come in quiz that in your final exam. What are the three conditions they'll give to, and what are the other conditions? First one is the deterministic Markov decision process. Immediate positive bounded reward. Obviously, immediate bounded reward should be bounded, particularly that immediate. Otherwise, it will be explode. Agent selects every action pairs infinitely often. These are the three conditions for convergence. Now coming to the Q function. What is Q function? Q, just think it as simple as a quality function. What it says, given a state, what is the quality of an action? So this is as simple as that. Now what is value of a state? Value of state means the how much that state is close to goal. This is how the value of a state is defined. In last lecture I told you, if someone want to be prof, if he or she is in PhD, then he is quite close to his or her aim, right? So value of PhD would be very high for them compared to another course like LLM, BLM, CLM, whatever, right? So this is the value of a state. So how you learn these things? You have a function, let's say you have a parameter W, you give just state to that function and it will give you value of that state. Similar thing happens for quality of action. So you give two things, one is state, another one is action, and that state and action will say what is the value of that action for a given state. It is not saying anything about the state, it is saying what is the value of action for a given state. A state might be very much useful for a given state, but that the same action might be not that useful for another state. So this is very important to keep track there. Is it good to go there? Any question, any suggestion till there? You can ask to if you have. Okay, seems like no. What is the relation between state value function and Q value? This is very important concept. So finally, how Q is coming? What is the row and its relation with the value function? Q, as I said, it's a quality of action. Value is a return of state, means gain or value of that state. How can you relate value in value function and Q function? So Q and value function is equivalent if you have this operation max of A over S. What does that mean? It means you are in state S. Let's say you are at the third floor of a building. You have options: go up, go down, stay there. Only three actions, right? So someone is asking what is the value of to being at third floor. You have three actions: up, down, and to be there, idle. So value of state can be calculated through quality function, but the thing is you should take the action which is giving you the maximum reward. So for me, going up is the best possible let's say option. So value of state would be, you tell me what is the quality of you are going quality of state for the given action A, means going up. That value represents value of the state. So this equation, please keep in mind, because there would be many questions which will be around that. You will have something in terms of Q, you need to find the value, or you will have some value, you have to find something in Q. There in quiz also you will have a very that I'll discuss in the later part of this presentation. So you will have those things. So please make sure that you understand things. Okay, so should I discuss also this part, because this is the mathematical and you need to understand finally what is happening there, how this equation are coming. Because if you know the concept and equation very well, you can just put the value and get the your numerical, get it done. But if you have confusion there, you cannot do those things. So please take it very seriously and understand. So what we are doing, we are just opening this equation. Max of A, let it be. We are opening this, what is q pi star SA. What will be the value of action A for a given state S. So we are saying fine, we are doing here as maximum likelihood estimation. If you see, we are saying for we'll have this R is independent, so this R will come out of it. There is nothing relation with the P, R, SA and R. Immediate reward, what you will get for that state, plus what is the value of its that next state. So for the running example, if I have to say what is the value of third to be at the third floor, it is equivalent to reward that you will get it for going at the fourth floor plus value of fourth floor. And does it make sense? So I am giving a very pretty clear example so that it will be very clear. So this is what it have done. Now it's not everything is deterministic. You cannot, you are going at the fourth floor, but what is the probability? So that they are calculating for the state action for being at the third floor, taking up action, what is the probability you will go at the fourth floor, S dash, and you will get the reward whatever you are saying that you are going to get. So P of S dash R given S and A, say S is third floor, A is going up, S dash is fourth floor, and reward that I'll get it for going to the fourth floor. Let's assume fourth floor my friend is there. So what is the reward of meeting him or right? So what is the probability? So so this overall this right hand side you can see R plus Y gamma of B star SA says what is the value of third floor, but it is in terms of reward of going fourth floor and then value of fourth floor. But the what is the probability of transitioning to the fourth floor also being multiplied, right? Because if I'm saying I may go to the canteen, I may go to restaurant. Going to the canteen is the probability of 0.2 and going to the restaurant is a 0.8, let's say. And then you can very pretty much sure that I'll cost more money, more likely, because the probability of going restaurant is higher. So and that, so it's like a maximum likelihood estimation. You are getting the point, right? So A1 into probability of A1 plus A2 into probability of A2. So here we are saying that's cool, we'll go to the another state, we'll go to the fourth floor, that's okay. But what is the probability you are going to transition at the fourth floor? Because in your equation there is a fourth floor value, right? You have a value of S dash, sorry. So this is why it has been put in there, this probability function. Now I think it's clear. Now coming to the third step, what is happening there? If you see, so it is summation of S dash R, summation, that is why it's a summation of S dash and R into probability of going to S dash R given S and A into you have these things, right? You are assuming that A you are taking is the maximum reward that is getting, that's why this term has been eliminated now. So finally Q star SA is equivalent to this number, which is probability of going to S dash R given S and A plus this typical reward term you have, it's a gain kind of thing. So R plus gamma, gamma is a discount factor, into max your Q star of next action, right? So I think this fourth equation is very critical you to understand it. So first I said V star, first equation, see V star is as equivalent as max of A given Q pi star SA. So you just open it, it's getting a immediate reward plus gamma into value of action which you are going to take, but which action you should take, that is giving you the maximum reward. That's why if you see in right hand side there is a term max at the last equation. If you remove the max and gamma, it's similar to gamma into V of S dash. So it's very clear, I believe. Now it's just a recurrent equation. So this is one problem if you see. So how good is state, what does that mean, what is that mean? So please take care of whatever I said. It's like how much close to your goal. So if from that state going to goal is very likely, means you are at a good state, right? And conversely, if you are at a state which is more likely to go to a terminal state or the dead state without being reaching to goal, it's more likely that state is not good. So for example, there are three states A, B, C, and from A going to B, probability 0.5, B going to probability 0.5. For B you are going to get a reward of 0, for C you are going to get a reward of +1. What is the value of state? Just enumerating with this example, running example, A is a third floor, you can go to the second floor and fourth floor, third, right? So B is, let's say, second floor and C is the fourth floor, because you are getting reward. My friend is at the fourth floor, while will go to the second floor, and probability of to the going both direction up and down is same, 0.5 and 0.5. So value of that state would be 0.5 into what reward you are going to get it for the next second floor, which is 0, plus 0.5 into 1 that you are going to. Now I think you people must have get confused, few people. What is the reward, what is the difference between reward and value function? Is it the same? So reward is something known as a feedback which is very immediate, whereas the value function is saying value of a state which is being calculated in terms of reward only, but it is considering both immediate as well as long term reward. So this is the difference. I need to take a call, just a second. हेलो, हाँ शायद, हाँ हाँ, फाका है क्या अभी, कोई यूज़ कर रहे हो? मेरा कुछ प्रोसेस चल रहा है क्या उसमें? तुम्हारा अकाउंट से? हाँ, स्क्रीनशॉट भेजो मेरे को, स्क्रीनशॉट भेजो, 73 में। नहीं, लास्ट में क्या है? लास्ट में 62 है। 62 में कौन यूज़ कर रहा होगा? मैं तो अच्छा, इतना बड़ा मॉडल है और खाली है क्या 4? कितना देर चलेगा? चला दो, गाली सुनोगे तो क्या काम तो हो जाएगा ना, चला के दो। चलेगा चलेगा, वो 90 तक भी जाता। देखना सीपीयू पर यूटिलाइजेशन परसेंटेज 800 900 1000 पार ना करे। टॉप करोगे, टीओपी करोगे ना, तो तुम्हारा दिखा देगा कि तुम्हारा प्रोसेस कितने परसेंट सीपीयू ले रहा है। तब तो ठीक है, कोई दिक्कत नहीं। वो 800 900 1000 मत क्रॉस करा। ठीक, चलो चलो। Yeah, so I was talking about what is the difference between value function and reward, right? So reward is more of a immediate, but values consider both immediate and long-term reward. Now coming to this calculation, this should be very clear to you people. What is Q state action value? So quality of a state is relevance of that action A for state S. So it is like what you are getting immediate, R immediate plus gamma into finally whatever to next state you are going S dash, right? What is the value of that state, which is being again defined in terms of Q to be have recurrence equation, gamma into argmax. If you don't put argmax, it's not useful here. So argmax, take action A dash, so it is A dash and the value of S dash and A dash. So coming to again the running example. Third floor, that's fine. You are going to 4th floor, do that, no issue. You will getting reward R immediate for that. R immediate I put it there. Gamma discount factor, let's say 0.8, I am putting there. Now saying value of 4th floor, how we are going to calculate it? It is being calculated again in the terms of Q, which is saying you are at the 4th floor, that's fine. From 4th floor, where you want to go? You have again going to the 7th, sorry, not 7th, 5th or 3rd. So it's A dash again become 2, 2 actions are there, 3rd and 5th, right? So you please select the action which is giving you the maximum reward. Fine, I'll go to the up, so which is like 5th floor. So A dash represents 5th floor, and then again value of Q of 5th floor comma A dash, and it will go again for 5th dash. You will have some innovation. You will go to the 6th floor, and 6th floor to 7th floor, and 7th is the highest floor in our hostel. So you get to know 7th is the final one. You have reached goal. So here, if you can you see the recurrence equation how it is coming. So R plus gamma into R dash for 4th floor plus R double dash into gamma square into value of the next and like that. This is the recurrence equation. If you will just open it, it will be like that. Finally, there will be term for going to the 7th floor, that goal you have reached. This is the final thing, and then you are calculating state value action of being at the 3rd floor. I think it must be very clear to you. Any doubt, any question you may have put there, no issue. So this is the state action value you are calculating in terms of cumulative reward, and you are putting state action pair. Okay, fine. Everyone understood what is the QS and how it is being calculated. Now how to implement it, how to do it. So it's just a Q table where if you see rows, these are the states. You have, let's say, 500 states, and you have 5 actions, not 5, 6 actions you have. So you make a table, put all rows as a states and all actions as column, and you have to learn this table in Q table, in Q learning algorithm. Finally, you have to learn this table. So each entry represent, if I come to this, let's say here, this one, what does that mean? It means what is the quality of action is east for being in state 0. This number represents that. It says 0, and if you have learned this table, then finally you are at the any state, just see which action is giving the maximum reward from the table, and it will say, okay, go to that action. This is how it is being, learned. And once it's learned, it's how it is being inferenced. This example, it is going to be there. So this thing, I think I saw it is in some assignment or somewhere. So this thing will be given, let's say this table will be given, and they will ask after these steps what will be the value of this one. This kind of question used to come. So it is saying you are at the start state, fine, what is the value of right? You are at the start state, cool. You have how many options? You have 4 options, up, down, and go. If from this you can see up, down, and left and right. But if it is this is the problem, then you are at the start state. Which one is start? Oh, if it is the current situation is start, you don't have up option. You have only left, right, and down. Down, you can see it is a ranger state, so that doesn't want to go. You can go to where? You can go to left or right. But again, from the diagram, it is clear that it should take right rather than left. At the both places there are cheese, but the amount is more at the, if you see, right bottom. So this is the question has asked what will be the new value for start and right. How we are going to calculate? It is like, what was the old value? Initialization has been done. In initial Q table, you put everything to 0. This is how initialization used to be done, right? So it is equivalent to what was the initial value plus what alpha is the learning rate, del Q. Del Q means what is the difference between start right. it means it is saying what is the estimation difference. Means you have done some work, that's cool, but someone is saying no, it is wrong, it is not appropriate. So okay, fine, that it is not going to work, let's okay, but was it appropriate at some extent? Okay, if it is appropriate, you take the action again, but also put the difference, the error term, what was expected and what I have done, into some learning rate. This is the intuition of this equation. So finally it is r of start of right equals to r of start of right plus gamma into, just they have opened that equation, q dash is a dash minus q start of right, and finally they have take the values from there and put it there. This value, see, they are saying reward for going right from start is 1, and they have used it here. Gamma is 0.1, gamma is 0.9, and finally you are going to some number which is 0.1. Please put 1 minute there and see. If you have any doubt, please ask me. Okay, fine. So going forward, this is very important concept, Bellman equation, and everything has been learned there, right? So what is this? The Bellman equation is one of way to formalize the connection between value of a state and future possible state. So just the enumeration, the recurrence relation they are saying. So this is the equation, B of S is equivalent to, you take an action but make sure that it is giving you the maximum reward. That's why the max operator is outside. So you are taking A, which is giving maximum reward, you are going to some state next S dash, so the value of that state into gamma plus what has been you got immediately from doing transition from S to S dash. This represents the first term R of SA plus gamma into future reward, discount factor into future reward. So if you see in right hand side, this is the bot where it is, how it learns. It says it has three things. If it cannot go down, it has up option, right and left. So what should it do? It depends on what is the value of S1, what is the value of S2, what is the value of S3, and it will select the action. It will select the action which will lead to, let's say, S3, because the value of S3 is the highest among S1 and S2 and S3. So this is how it is being learned. So this is again the generalization of the same equation in terms of Q. Yeah, yep. This thing I discussed last week. If you people were there, then it might be very clear how these things has been done, how these values has been calculated and all. So just one equation I'll explain, because this kind of problems would be there in assignments. So robot at the, let's say, S9. So it is asking what is the value of S3. First it is being calculated, which is equivalent to max of, you are at S3, that's cool. From S3 you take an action which is giving a maximum reward, plus wherever you are getting, you take the gamma into the value of that state, S dash. So it is like R of SA, and R of SA from S3 you can see going right is the only best option. So it is going to the right, which is giving the reward of 1. So 1 plus gamma into what is the value of this state, the diamond one, and which is here defined as 0. So gamma into 0, then finally the value of S3 is 1. So this is how it's being calculated. What is roll-up discount factor? So if, let's say, you don't have discount factor, why? Yeah, same example I used to give. Money today is worth more than the money tomorrow. This is a very, very important concept you might be getting. So it is saying you are learning from reward, that's fine, but give more importance to the immediate reward compared to the reward that you are going to get in future, so that it is like a kind of balance. So R1, that's fine. you don't take complete R2, you just do some fraction multiplication. So if gamma would be between 0 to 1, if it is less than 1, then the R2 would not be R2, it would be some part of R2, right? So that's why gamma into gamma square, again if it is let's say 0.9, then again it will be reduced, 0.9 square it will be 0.81, reduce into R3. You take R3, but compared to R2 its importance should be less, and like that this equation look like. So the goal of intelligence is to maximize the cumulative sum of a single received number, right, which is reward equals to pleasure minus pain. General artificial intelligence equal to reward maximization. So AGI, general artificial intelligence, is saying like you learn a task which is finally doing reward maximization. Reward maximization means what has been expected, it is reaching to the maximum thing. Exploration exploitation. What is this? It is I explained you what exploration and exploitation thing. Explore means when you are at the initial part of training, when an agent is at the initial part of training, it explores a lot of things. It actually don't have any knowledge now, so it says before action, right, left, up and down, it will try to do everything, and then later understand, okay, I did everything, but right from going right it was good action, because 10 out of 8 times I have 8 out of 10 times I have reached to goal if I have took the action. So in that way it understood that information, and in later on it exploited it. So should we do exploration or not? Should we do always exploitation? This is the big question. So if you want to buy a phone, that's cool. So when you want to buy the phone, today, tomorrow, let's say today you want to buy it, you explore it. You have A, B, C, D, E option, but up to when you should explore? Finally, when you are going to, with that gain information, you are going to buy a phone. So this is exploitation phase. So both are required. You need to explore, that's cool, but you also need to exploit that information finally. So Gamma Greedy says in initial part of training you do exploration, but with some probability you do also 1 minus gamma, you take the greedy action. Gamma used to be very less, it used to be less around 0.1. if you have fixed, means only 10% time you explore, 90% time you take the information of the you have learned, that QSA value. You have 4 action, left, right, up and down. So it says that with 10% time you don't say any value function, any action thing, you just do the random. It's like a random between 0 to 3. But 1 minus gamma, which is 90% time, you all use the greedy technique you have, the function you have, utilize that information. Lower gamma over time, this is very important. So as you grow, you need to do more exploitation because you have learned a lot of things. So reward value function policy, this one slide says everything. These 3 terms you must be hearing in all last 1 or 2 weeks. Even the next week you are going to hear these 3 terms. So make sure you are understanding it very correctly. What is this? So they are very much interrelated. You have value function, you have policy, you have reward, and reward is something which is giving you a sense which policy is good or value function is good or bad, which value function you should select, right? So reward is the ultimate thing. So from reward itself it is being sensed what would be the optimal policy. A learned time varying prediction of immediate reward, key to all efficient methods for finding the optimal policy. Yes, so I have shown you in the previous slide how policy and value function can interchangeably use, but they all are based on if value function can be converted in policy, means both are in policy, and policy depends on what? It depends on reward. So you finally learn a policy which is giving you the expected reward, maximization of that, right? Yeah, so this slide says what is the difference between supervised learning and reinforcement learning. In supervised learning you will have input and output, right? So input and output label we have, your model will be trained in such a way that it it should learn to do the behavior of output, whatever the label you have. So finally you are giving input to the model, it is doing output, let's say, and you have some actual label. So you are doing target output minus actual output, what model has generated and what was being needed to be generated. So just do the error of those things and being back propagated. You have x and y, but here we don't have x and y. We are giving input to model, that's fine, and outputs are actions. Which action should I take? Left, right, up and down. What is objective? Objective is to get the maximum reward as possible. So in some sense you can think reinforcement learning as a supervised learning if you are doing feedback as a reward. That reward is giving you the sense that which action is good or bad. So reward is the only signal that says how model used to be trained, right? Credit assignment problem, I think you people have heard this term. It says that Pong, you hit the battle, 20 frames later you earned the point by passing the opponent's paddle. Yeah, so this is very problematic thing. The giving example, I finally reached to the 7th step, 7th floor, but what action was good? This is something it used to be asked, whether it's a fourth, going from 4th to 5th was good action, or going from 3rd to 4th one was the good action. Both are good, let's say, if in this scenario, then which one was the better? So credit assignment says you have reached to the goal, but which action has mattered the most? So this is known as a credit assignment problem. So if you can see this image, I used to think correlation implied causation. Then I took a statistic class. Now I don't. Sound like class help me. Well, maybe. So he has or she has some problem. She took the class something, and then that problem has solved. Then she was thinking whether that class was helpful or not. Maybe or might not be, because in that statistics she learned something, but with other things also she has learned. So she was a bit confused whether that statistic class helped or something else has helped. So this is known as a credit assignment problem. So now what is sparse, noisy and reward? So finally, whenever you will be expert of reinforcement learning, you have to do only one thing by yourself, is the reward designing. You have to design how to do the reward. So you can see this example, how reward shaping, what does that mean? Let's say I have to learn a task which is a dialogue generation, for example. Given a context, what a bot should say, what a chat bot should say. I'm talking with a chat bot, what response it should do. This is the problem we are translating into reinforcement learning problem. How it could be done? We want something it should generate so that whatever my impression for the chatbot is, it should be positive. It should not be negative, right? So this satisfaction, whatever I'm giving, is the reward. So maybe sentiment of my response for a given chatbot response can be treated as a reward. So reward used to be sparse. Sparse means the number would be only high if it has reached the goal. So in real life you must have learned process is more important than result. Process is more important than result, right? So it is same as that. You have you need to be you need to know the process. Finally A1, A2, A3, A5 and A6, and then you have got the result. It's not like you have, if your reward would be very much sparse, then you might not be correlate which action was more better. So this is the problem of sparse. One example I can give you. Let's say you want to train an agent to play chess, and you are giving only reward if it wins, and you are giving penalty when it loses. This is the only as simple as reward. Then it is quite sparse, because it is not learning the process. It has to also learn, given the context, given the chessboard situation, if it has done left, right or up and down, whether it is going close to a goal or not. If those things also you need to encode. This is the concept of balanced reward. There is a term called reward hacking. What is the reward hacking? You must have heard ethical hacking and all those things. What is reward hacking? So maybe the agent, you want one thing in your agent is that it should do reward maximization.
Reward hacking was not taught in our class. Okay.
Oh, really? Yeah, it's pretty simple idea. You are doing the reward maximization. So maybe model has learned the same behavior reward maximization, but whatever the underlying task, it may not be satisfied if you have designed reward in that manner, right? So this is the reward hijack problem, hacking problem. How to design a good reward function? I already talked about that. How to design a good reward function. So reward should be quite balanced rather than this kind of sparse reward. If you have, let's say this is the equation you have, you are giving success for +1, you are otherwise you are giving 0. So model has only learned how to reach goal, but what is the process it has forgotten. If you have designed something reward like this, if it is reaching success, you are giving +1, that's fine. If it is not reaching, you are giving 0. But also you are giving immediate reward for each action. You are giving something, not only the terminal action, you are also giving reward for each state. Is something known as you are making it to learn the process more smoothly. So here it is distance of s dash and g. So the example I gave in the last class, it has to the bot has to reach to the gate. So whatever action it is taking, let it take, and whatever the next state it has reached, s dash, you see now the distance between the goal and s dash has been what it is reduced or not. If it is reduced, then you say okay, whatever the action it has taken, it's quite good because it is going close to the goal, it is going close to the door. This is known as a, so if what we did, the first one was the sparse reward. We did reward shaping. We try to encode the process as well. So this is known as a reward shaping thing. Now some application and then some numerical, we'll discuss about that. So these are some trending things which is happening through RL. So I think you could able to see this slide. So this is one in left hand side, autonomous helicopter flight via reinforcement learning. So NDNG, Stanford, their team has done this thing. So they are training autonomous helicopter flight, so through reinforcement learning. So it has learned through RL technique whether what action it should take. For this scenario, it may be go up, maybe go down with speed, and some this kind of action would be there. So this has been trained with RL part. I think I had some video for that, how it started learning. It was very sparse reward, it fall down many times, then reward shaping has been done, then it came to some good path, and then it learned. In right hand side, there is a group at the Boston, so they are doing this kind of thing. There would be a robot which can do a movement, so you can see it is doing quite a good movements and all those things. This is one another improvement is the arm movement. So robot, this is a robot and it has to do arm movement in an appropriate way. So it is like putting from one hand to another hand. This is what it has been learned, and this is what it is doing. In the top, this is the human perception, and how finally in the testing time, model has learned to do these things. Wherever it box may be, it needs to go get it to close to the another hand. This it has learned. So it was done in 2017. Another one, as I said, how to do a kind of this stuff exercise and all those things. So from human imitation it has learned. So what is human imitation? How humans do, it has tried to imitate that process. So this is what, so now robot has reached to that state that it is able to imitate human experience at some extent. Now coming to the few questions, I'll discuss about few questions. So before that, any question suggestion?
Sir, have you discussed the assignment questions, sir?
Not yet. We'll discuss currently the few important concepts, and then we are going to discuss about these questions. So for RL, when is the assignment due?
Sir, it is next week, sir. Sir, the week which was over, main this one, 10th week, sir, which we gave day for yesterday. That
So
that assignment can be
for this
RL is
week,
not. Yes, sir. RL is upcoming week. I mean, that assignment we didn't give it now yet.
no, it's open the assignment. This is the RL week, right? So this week has been
Yes, sir.
dedicated for RL. Am I correct?
Yes, sir.
So
But we haven't discussed the previous, I mean, that before one
MDP
question,
we
sir.
discussed last week itself. MDP are you
Okay.
talking about? So last week. So in my class I used to do like that. So what I used to do, the current week we discussed few important concepts and some questions related to that itself, some numericals. So I don't take the current week question. I used to take the previous year NPTEL itself questions or some other important numericals and I discuss. Give me a minute, then we'll go to the question and discuss. Till then,
Yes,
just
sir.
yeah.
Some questions are like doubtful, sir, for numerical solving for last week. I mean, we got like almost everyone got it wrong, sir. So that's why that is a bit crucial.
Oh yeah. Okay, so let's come back to the questions what we had last week and this. So this is the question: what is the key point about the reinforcement learning in a strong simulator setting? I think you might have known about the what is a strong simulator setting or what. Simulator means you that reward model we need to design, right? So how we can do, we can put a human imitator and that is the user simulator. So given a context, given an action, what reward it should give is the user simulator. So there are four options. We don't learn the transition or the reward model but directly learn what to do when. So it is saying fine, we don't want to get an idea about the reward model but directly learn what to do and when. The agent cannot teleport to the any state and is restricted. The agent can jump to the any state and start simulating from there. Agent learns both optimal policy and state value. So these are four options. What would be the correct one? Just think for a second and then I'll tell you what is the right and why it is right. Okay, fine. So first option is saying we don't learn the transitions or the reward model but directly learn what to do when. So it is saying we'll not learn how to go from S to S dash or the reward model itself. We are not going to consider R, what is R and all. We are directly going to learn the policy, which is not possible at all. Finally, the policy effectiveness is sensed through reward itself. So first one is obviously not correct. The agent cannot teleport to the any state and is restricted. The agent cannot teleport to any state. It is saying the agent cannot go from one state to another state. Why it cannot go? And it is restricted. No, there is a simulation and that can mimic the behavior, so it is also not correct. The agent can jump to the any state and start simulating from there. That's true. We have the simulator and it can simulate the properties. So agent can jump here and there, do the exploration and finally learn. Agent learns both optimal policy and value function. What is need? It can learn only one thing and from there other thing can be mapped easily. So it needs to learn either of it, right? So the option would be third one. The agent can jump to any state to another state. This is the right answer. This is another question. Does adding a constant to all reward change the set of optimal policy in episodic task?
I think no.
So the question is saying you have the reward, you have designed the reward model. Let's add some constant. It may be positive and negative, both. Just a trick I gave you. So will the optimal policy set of optimal policy would change in episodic task? What is episodic task?
Sir, it may be possible that the action depends on the magnitude of the state, reward. Then it may change, I think.
Okay. So you are saying
Depends.
it may change.
Yes, sir. Depends upon the policy, sir.
Okay.
I don't think it is possible to create a policy whose actions are determined by the magnitude of reward rather than the relative difference between rewards. Because the policy, of course, when we move to the state which gives the maximum reward, like you don't move to a state which gives like 2 reward, you move to the state which have like the greater reward. So I think the answer should be B, no.
Okay. Anyone else want to comment?
Sir, like heuristic functions and all, like we did that MDP also. In that, the cost also determined and also difference also matters. But I think the magnitude also it may matter, sir. So, don't know,
Okay.
sir. I think it matter. It may matter. Depends upon the design.
Any other suggestion or comment on it? So question is, I think, very clear. It is for reward. I decided let's do +5 to the every reward. Will the set of optimal policy will change in episodic task, or it may be -5. The set of optimal. What is the relation?
I think in certain, like for example, in one policy where like the professor discussed, where we are not 1/1 minus 1/1 + 1 was the alpha, like when the alpha was not fixed but changing with the number of steps. In that case, if we add +5 to all rewards, then the policy will change. But if the alpha is constant,
Okay.
and not changing with the number of turns, then it would not.
Okay.
Because in
Anybody
that
else?
case, the policy actually is dependent on the initial value of reward, right?
So there is another important term is episodic tasks, right? So it is very crucial. So you now think about that also. So you people have missed that term.
Yeah, okay. So in episodic task, yeah, then it's B. If it's episodic task, then you're going to refresh it anyway.
Yeah, think for a moment and then, because this is a very crucial term. If I change the episodic to the continuous task, the answer would be different.
So you're asking like the reward is added to all the tasks or like one episode and not to other?
No. I think you people are
So,
getting confused. So it is as simple as that. So this was the reward, na? This was the reward 2 model you are seeing. So it
okay,
is
so if
saying
the reward is added to all the
all the
episodes,
components. I'll
okay.
do +C to all this. It would be 1 + C, it would be 0, it would be D C S dash G plus C, something like this.
Then it should be B.
Anybody else want to comment something? There are two options. First one is saying adding a constant to all rewards, whatever the components you had, A, B, C, let's say 3 conditions. Putting reward changes the set of optimal policy. No, as long as the relative difference between the rewards remain the same, the set of optimal policy is the same. So this was the question. What would be the answer? So as someone has already pointed out, yes, adding a constant to all rewards would change the set of optimal policies. It is true, because adding a constant signal can make larger episodes more or less advantageous, right? So what is happening, if you see, that's why I said this episodic is a key here, because if you are doing something -5 to each component, then you are telling model in some sense you shouldn't do the task for a longer time. So that is why here episodes is matter. So longer episode more or less advantageous depending upon the whether the constant is positive or negative. Is it clear now? So adding to the constant will lead to the change in set of optimal policy. Now as I said, the same question would be there. If you remove the episodic thing, then it will be different. Question is same. Does adding a constant to all rewards change the set of optimal policy in continuing tasks? So it is continuous task, not a episode task that you have means fixed things. You have a continuous task. What would be the answer? Yes, adding a constant to all rewards changes the possible. So yes, no, as long as you have the relative difference between these rewards remain the same, the set of optimal policy is the same. So here, if it is a continuous task, then the set of policy is not going to change, because after it will accumulate the same kind of extra reward independent of its behavior, positive or negative, like that. Next question, write the policy pi star in term of q star. Very easy question.
B.
Okay, you're saying that B1 will be possible. Pi star of A of dash equals to max of A dash. So what pi
Like pi star gives the probability, right? Wait a second. The pi star gives the probability, right, of choosing action. Then it's C.
Exactly, it's true. Anybody else want to comment there?
Sir, can you explain that C argmax that?
Yes, definitely I can explain. So see, first I'll explain the first, second, and all three options I'll explain. So question is, can you write pi star, the optimal policy you are learning, in terms of q star, the quality function you have? Option 1 is saying pi star represents the optimal. A given S, what is the probability of A given state S, which is equivalent to q star of SA. QSA, what is the optimal value for taking A in action in state S. So right hand side you can see for the first option is a value, whereas in the left hand side is a probability. So this is not going to work, first one. Second one is saying pi star A of S is equivalent to max of A. So if you go inside after max, this is again a value, q star S of A, but left hand side is a it's some probability, which is again not going to work. So first second is first second are elementary. Third one is the pi star A of S is equal to A if A equals to argmax of. Optimal policy means you have reached to the state every time you will do the best action you are doing. This is the meaning of an optimal function or optimal policy. So if I know A is the best action for state S, this is why in the if condition it's saying A is the argmax. You are enumerating over all action and checking, and finally you find out A is the only action which is giving maximum reward for a given state, right? Cumulative. So you have very much deterministic that you should take A, right? Because it is giving you the maximum reward. That's why pi star of A of S, we are expecting the probability should be 1 because it is giving you the maximum reward. That's why option C is the correct answer. Does it make sense? Okay.
Okay, sir.
Okay. Now coming to this question. This question is very interesting one. Even though I discussed it once, I'll come back to again, and I need people you to solve it because many of you are not there in the last class, and those who will do this, we should do some kind of what should bonus marks. Not marks because it is not in my hand. Something else bonus. But try to solve it. It's a very interesting question.
I think the steps as a parameter is very high. That's why this is jiggling back and forth.
Oh, should I explain the question? You see the question what it is?
Can you explain the target and estimate?
Yeah, sure. Yep. So in RL, what we want finally we want that policy to learn a distribution. So this blue curve says what it says. This is the target estimation of a value. Let's say it is the Q value only. So the real value, the target one, is saying this is how it should go over the time. But estimate that we have the red one, it is happening like that with the current Q function. Then you can see what is the error between these two, right? And then you can back propagate it. So if you see the equation Qn plus 1 equals to Qn, what was the previous n? Q value at n plus 1th term is equivalent to what was the Q initially and what was the error into alpha. Alpha is learning rate. So it is asking, this is the curve, this was the target situation, and this was the happening. Can you tell what is the step size? Step size means what is the alpha that you have to find.
Since the error seems to be differing as the time goes on, I think the step size parameter itself is a function of time. So I think it should be D. Maybe.
Okay, let's see what other says. You are doing very short estimation, isn't so? You should take some time because other option could also be possible. So this is just have to put the values that the top equation and find out what will be the value of alpha. You just select few values in from this curve and put it there. You will get it the alpha. And it's as simple as that.
Yeah, it's 1 by 2 by calculating equations.
What's your name?
Swarnim.
Sonia. Okay. So how we did it?
So 3 equals to 2 plus 2 alpha. 3 is the third step value.
Yeah, it's
Equals to
correct. So let us solve it. How you have done it. 1 by 2 with answer. I need to take a tab. I used to find really hard time teaching. Other TAs are how they are teaching. They are teaching the slide or they are using tab.
they are using both.
Oh, there isn't good. Who are the other TAs? Harsh and what is his name? Gunjan.
Actually,
Harsh
the
is not
Professor
available.
Harsh, Yeah, the professor is not attending class, not taking classes since like 5 weeks or so. Only Gunjan, T. Gunjan is taking class,
Oh, he's very
and he,
sincere. Every time he used to take class and all those things, I have seen his seat is always filled. Gunjan
yeah,
is
yeah,
the
yeah, like
very good tea. So you people need to give also feedback about those things, or just we put it the sheet and you watch it like that.
we are supposed to give feedback. There are like feedback forms where we are supposed to give feedback to various TAs and exams and questions and everything.
Mm-hmm. Maybe at the end of this course you will get that option to do that.
We get that option weekly.
Oh, weekly you used to get.
Yeah, weekly. We at the end of a week we are supposed to give feedback on the assignment and the TAs and the lectures.
Okay. This is nice. So it's a continuous process. It can be no, but it's not being shared or something like that. So.
I don't think anyone is looking at it, considering when we ask like questions on the forum, the official forum, like no one responds there.
Where is the official forum? Can you give me a link in chat box?
It's a Google group. Yes, I can give you a link.
Okay. It's a Google group, and there will be a lot of people. We are not there. TAs are not there. So maybe one head of this NPTEL course, professor would not also be there. So, and the people who would be there, he might be from administration. So he is not
Sir,
supposed
so
to be
like
there.
for example, there are some certain assignment questions which I think are simply wrongly marked. What should I do with them?
Oh, have you mailed and they didn't respond?
Yeah, I have mailed them and they don't respond.
Give a gentle reminder. Have you given a gentle reminder or something like that?
No, like they don't respond like to any question.
Oh, that is it so. So whom you mailed? NPTEL.
We don't mail. We just have this Google group which I send.
No, they're how they're not going to work. So there must be some contact email ID, right? So from there you mail, they'll look upon it. At the
Okay, so I will
course,
try that.
yeah, yes, there that is. So now coming to this question, I don't know. Swarnim has solved it. So this is one option. I took it there. If you see, let's consider n equals to 1. So this is the n equals to 1. We put the equation which is qna plus 1 equals to qn plus x into rn minus qn, right? So qn plus 1, what is the value of qn plus 1? We are considering n equals to 1. So we need to see what was the q2, right? So if you see the q2, what was that? It is 3, the red bar, you can see the second plot. So it is 3, we put 3 equals to qn. What is the qn? At the current estimation is 2. So that's why you put the 2 plus x is our point of interest that we need to find. Rn, what was the true value? So we are seeing what is the true value at the 2, it is a 4. So we put 4 minus what is the qn? It is 2, so it's like 1 by 2. Is it clear to everybody?
Yes, sir.
Okay.
Sir, for n equals to 0, I think answer is something different. Put n equals to
For
0.
n equals to 0, let's try. So we were saying let's try for n equals to 0. So it would be q of 1 equals to q0 plus x into r of 0 minus q of 0, right? So if you do it, it would be q of 1 is how much? Your estimation
No,
at
sir, it's same. It's same. It's same.
it's same,
Same,
na?
sir.
Okay.
Same.
Another question is gamma. Gamma is a discount factor which is 0.8, and you have the reward sequence. R1 is 1, means the first reward you are getting is 5, followed by infinite sequence you are getting 10s. What would be the g of 0? What would be the gain? I explained the question bit, in more better way. It's saying gamma discount factor is 0.5, that's fine. The immediate reward you are going to get is 5, and afterwards you are going to get 10 every time. They are asking what will be the gain of this, with the g0, what is the gain? Try to calculate. So it is very simple. Just put the return equation, which is what was the equation for G? It was immediate reward plus gamma into long term reward. So you just put it there and do. You will get it.
It's 55.
It's 55. Someone is saying. Anybody else have any other answer?
Wait a second, I don't know, I forgot the GPs. Like if the first value is like less than 10, like how am I supposed to calculate a GP? It could be 45. I think it's C because yeah, it's C 45.
Okay. So in last question you have got a bonus, right? You told the right answer 1/2. Am I correct?
Yeah.
This time it's negative marking, so it becomes 0. I don't have to give bonus now to you. So 45 is not the correct answer. I don't have to take
Like
this
I
bonus
I
burden.
forgot how to calculate GP, man. I forgot how to calculate GPs.
GP, geometric progression you're talking about, right?
Yeah.
So it is a plus ar plus a square is equivalent to a by 1 minus r. If your r is less than 1.
Yeah, but what if the first term is not the real term, right? What if the first term is like deviant from the GP?
You do
How do you?
plus, you consider the GP from second term onwards, where you just put first term as a constant, 5 plus, and then the GP value.
So GP will converge to one value, and you can just add 5
Yeah, exactly.
on bonus.
Yeah.
But the first value is not 10, right? The first value is 0.8 times 10.
I am saying, let's say you have something like P plus AR plus AR square plus like that. So how will you sum it? P plus that geometric progression sum. One part is not geometric, but from here itself you have the GP. It is going to the infinite. That you do P plus A by 1 minus R, as simple as that. So here P equals to 5 and
55, sir.
55 is the correct answer. So this is how it is being calculated. Initial term P plus gamma into 10 plus gamma square into 10 plus gamma cube into 10, like that. So take 10 as a common, and then this is the GP thing, which is A become 1s now. First term would be 1 if you take the 10 as a common. It would look like the equation would be 5 plus 10, then bracket 1 plus gamma square plus gamma cube plus dot dot dot, and it is the sum would be 1 by 1 minus gamma, because gamma is less than 1. If otherwise it would be done like 1 by gamma minus 1, I guess this was the formula. So for this case it would be 1 by 1 minus gamma. If you put it there, 1 by 1 minus 0.8, which will be 1 by 0.2, and it is 10 by 2. So 5 into 10, 50 plus 5, which is 55. So 55 would be the right answer. Now coming to this question, given equation for pi star in terms of b star and for argument p. This you have to find which one is the correct.
D.
Okay. Anybody else has any other opinion? So it's quite similar to the question we discussed just before few slides. So try to use the same concept and get it to the answer. Okay, so we can discuss the solution then if anybody don't have answer. So first were easily eliminated because this is the something probability distribution, it is not going to work. So solution would be this for the fourth one itself, so whatever he said. So it is pi star a of s. What is the probability of going to a given state s? That we need to find out in terms of b star, what it would be. So it's not D, it's C. So if you see why it is C, why not the D, is because you are also considering this probability B star of S is equivalent to summation of S dash and R and P of S dash and R. The equation we discussed at starting of, when I was discussing the concepts. So this is what it is here. So along with the going to S, that's fine, but what is the probability, what is the estimation that you are going to reach? It is not deterministic. It's that you take S, at A you are going to reach to S dash. What is that transition probability? It is also being multiplied here. So summation of S dash R, P of that component into the similar one whatever we have, R plus gamma into B star of gamma into B star of S, like this.
Isn't there like a max, like you have to consider like the whatever action that gives the maximum value?
Whatever the action has been given. So if you see this component, the third, the C option at the gamma into B star of S, that is, it is considering somewhere B max one. But
Yeah,
here,
but what is the hash dash? It's not defined, right? You have to consider the hash dash which have the maximum value, no?
what is the S dash? No, we are taking estimation over all state S dash, means you have the 10 possible S dash. You are taking from S to S dash, what is the probability? You have, let's say, 3. You are taking that probability and multiplying with the gain you are getting, right? Or if I am missing something, let me check me once.
I think you take a maximum over the maximum reward. You check for all the actions and you choose the one which gives the maximum reward, and the value you get from that action is the V star, right?
Okay. No, I think I saw something inconsistent with the fourth equation. That's why. So let me check it on max of A dash. That's fine. We are going to take A dash. S dash into R and then the probability term plus R plus gamma into B star of S dash S0. So the only difference between these two is max 1. Isn't so? Yeah, the only difference is max of A dash, and then you are doing R plus gamma into B star of S, otherwise 0. So if you see this fourth equation, there is a problem. If you are taking max of A dash, why you are going to bother about then S dash probability? It doesn't matter.
Yeah.
Finally you are going to take A dash, na? So it has nothing to do with that.
No, but it matters, right? For example,
it matters. That's why it has been considered in the third equation.
But you are not taking a maximum in the third equation. The value, the formula of A star has maximum somewhere, right? Because you need to choose the action which gives the best value.
So see, I have only two options, so that equation will make it very clear. I think somewhere I wrote it. Yeah, this equation, if you see. So this was the situation. You are at the A. This is the current state. What would be the value of A, which is likelihood of going to B into value of that state plus likelihood to going in C into value of that state. So B of A equals to likelihood is 0.5 for both. So reward you are multiplying with them. So this is there. So same thing they are doing here with the same idea. The likelihood has been multiplied here. Yep. So this equation, if you see, likelihood has been multiplied. So in some sense you are saying you are going to take the value in consideration which is the highest component, probability component, because that the probability would be high and that value would even though less or high, that doesn't matter, but that probability will be high, right? That P of going to S dash. So you want to pick an action, going to that action reward should be maximum, but also that transition should happen. That probability should consider. This is the key you are missing. From third floor I can go to the fifth floor by some way, the probability is 0.1, but from third to fourth going probability is it's very high, let's say 0.9. Reward for fourth is less, it's 80, for fifth it is let's say 90, but I'll take this one because this has 0.9 into 80 and that one has 0.1 into what I said 90 na? So that one. So if you compare this like that, so that's why they are considered also likelihood estimation. Does it make sense? So likelihood component you people have missed and it seems like, so you need to check it there again. So that component is also important.
The reason that the formula in that formula you gave was that we were not even considering the action because there was no action available. The probability was simply 0.5. And that's why that formula without, you can consider a formula without a max. But if we are given several possible action, the value is determined by the action which gives the highest value, right? So there needs to be some sort of maximum function in the formula V star S.
So this, if you go deeply, these are egg chicken problem. So it's like a probability of going S dash. It is,
yeah, I understand the probability of going to S dash, choosing like probability of going to the state which we intended to move is like should be taken into account. Right?
exactly, yeah.
But you also have to take into account that there can be several actions available, and you have to choose the action which gives the highest value. Right? For example, like let's say you our objective is to move to like the highest floor, and like we are in the fifth floor.
Okay.
Now I can like just jump down to the window and like move to the first floor like in an instant, or I can just take the stairs and for up and like move to the higher floor.
Okay.
In the choose to action, the value of my floor would be determined by the fact that I can move to the upper floor by the stairs, not to the fact that I can jump down the window and go to the ground floor instantly. So yeah, we are taking the maximum value of the action, right? But where is the maximum value in the formula of action? But
no, it is implicitly being considered. If you are someone who are likely to jump from fourth floor to the ground floor, probability is 0.9, that needs to be considered, right? And 0.1 into going to the fifth floor. So if you, let's say this situation only I'm considering, so your probability from jumping from fourth to ground is very high, it's a 0.9 into some component that you are getting some penalty plus going from 0.1 to that one. So you are considering value of state in the both terms. What is the likelihood and reward you are getting? If reward is very high, so implicitly you are choosing the action which is giving max. So max operator is inside that. If you think deeply, it is there itself. Okay, so if it doesn't make, again, since if I'll get the time, I'll again go more depth and some references and get it clear. Okay. So this, select the equation corresponding to Q star V star for the, is it the same question? No, it is in a different form. So what would be this Q star you have to find out in this theory which one is there. So then it may relate with the previous one. It's pretty easy. So just see where is the gamma, and from gamma itself you can able to distinguish. In the first equation there is no gamma, so it is not going to work. In second equation there is a gamma, but it is also with the immediate reward. This is again going to not work. Third one, gamma is at the appropriate place. So option here would be the third one, because gamma at the proper place r plus gamma into b of n, because you need to consider gamma, right? Gamma is the discount factor and it cannot be just like that.
Yes, sir. So next question, sir.
Yep. So this question we discussed, I guess. So next would be, I don't have any other question to be discussed, and if you have anything in queue that